our Chapter 5, Days 1 through 3 in class review. So today you're going to work through some problems with me on the video, and then you're going to mimic the same exact problems on the review that the sub has for you. So again, take your time through the video, press pause, press play. If I ask you to try something, make sure that you actually try it so that you're understanding what's going on. This sums up the past 3 days that we spent together on Chapter 5, and hopefully it helps you out if you were confused, especially on problems 1 and 2, which I feel like a lot of you did struggle with. Okay, so let's take our time for number 1 and 2. It says multiply the factors in the function below to put them in standard form. Now remember, standard form is just descending order with the powers. So like x cubed plus x squared plus x plus 1. Okay, it goes in that descending order. Okay, so we have number 1. The first step here, again, if I were to cover this piece up, okay, if I were to pretend, don't do this, but if I were to pretend this wasn't here, don't get to your notes, but if that was not here, what you would probably tell me to do is to distribute, which is true. So I'm going to take this 2x squared and distribute it into the x. When I say distribute, that means to multiply. So 2 times 1, because there's secretly a 1 right here, is going to get me 2. And then x squared times x is going to get me x cubed. Because remember, you always add exponents when you are multiplying. Okay? When you're adding exponents, 2 plus this 1 right here is going to get me the 3. That's why it's 2x cubed. Okay? So then I have 2x squared. Did that. 2x squared times negative 2. So there are no x's for that negative 2, so we're just multiplying the 2 times the negative 2. 2 times negative 2 gets me negative 4, but then we still have this x squared that's just going to come down for the ride. Now this guy is now in its own group, okay, because when you distribute it in, it becomes a group. But now don't forget, we had this guy that I crossed off in the beginning. He's still hanging out, so I'm going to bring him down in black because nothing has changed. So now I'm here. I have 2 terms, 1, 2 times 2 terms. So that means I'm going to have a total of 4 terms, most likely, because 2 times 2 is 4. But remember how we do this. We do exactly what we just did, but for each and every term in the very beginning. So I'm going to take this 2x cubed, and I'm going to multiply it to the x, and that's going to get me 2x to the 4th. Again, because 3 is 3, the power of 3, and the power of the 1. When you add them, you get 4. Okay, if I have 3 x's and 1 more, I now have 4. Okay, so then I do 2x cubed, multiply it to the 3, and that gets me 6x cubed, because 3 times 2 gets me 6. There's no x's for it to multiply to, so I'm just bringing down that x cubed. Now this guy is done. Some people like to cross it out when they're done so they know that we can move on. Now this guy, remember that negative 4x squared, that negative is attached. So negative 4x squared times x gets me negative 4x cubed. Again, because x squared times x is a total of 3 x's. Negative 4x squared times 3 gets me negative 12x squared. Okay? So now I have these two together. Now that you did all that, we no longer need parentheses. And like we predicted, look, there's 1, 2, 3, 4 terms, because 2 times 2 gets me 4. This guy is done. We're done with him. Combine like terms if we have any, and we do. In this situation, we have 6x cubed and a negative 4x cubed. We can add them or subtract them in this case together because they're the same thing. They're both x cubed, so we can put them together. They're like terms. So I'm going to bring down my 2x to the 4th. And when you add these together, which in this case we're subtracting, 6 minus 4 gets me 2. That x cubed just comes down. It's like if I had 6 apples and I ate 4 of them, I now only have 2 apples left, but I'm still apples. It didn't change to bananas. All right? And that's a weird analogy, but the x cubed stays the same. Now we bring down that negative 12x squared because we're just bringing that down, and we are all done. And it's in standard form because it goes 4, 3, 2. It goes down. Okay, so that is our standard form. That is how we multiply that all out. Okay, let's move on to the next one. Here, now this one's kind of a little bit of a different situation because this guy has a squared. We cannot, again, we cannot distribute this in until we write out this first. We first have to rewrite it. So I'm going to put equals negative 2x. Now this part's changing in blue. It's going to become x plus 2 times x plus 2. Because that's what this squared means. If I said 3 squared, that's going to get me 3 times 3. So x plus 2 squared is going to get me x plus 2 times x plus 2. Now we can do exactly what we did on the last problem. Pretend that this guy is not here, and let's distribute him in. Again, please don't cross off the x plus 2. It's just kind of for a demonstration for you. Negative 2x times x gets me negative 2x squared. And then negative 2x times positive 2 gets me negative 4x. Okay? I'm going to put them in a group because now we're going to have to multiply it to this one. I'm going to bring him down though. So in black, nothing changed. I just brought that x plus 2 down. Now we're going to go ahead and do exactly what we did last time. Remember, you have to treat each one of them separately. You have to multiply both of them to the other two in the other group of parentheses. So in green, negative 2x squared times x is going to get me negative 2x cubed because x squared times x gets me x cubed when you add the exponents. Do it again. Negative 2x squared times 2, which really just is negative 2 times 2, which gets me negative 4. That x squared just kind of comes down with it. Now this guy in green is done. Now I'm just going to go ahead and do the blue piece. So I have negative 4x times x. So negative 4x times x gets me negative 4x squared. And then one last one, negative 4x times a positive 2 gets me negative 8x. Now remember, when you're distributing, it's always going to be multiplication. Now we have to combine like terms. This guy is x cubed, then we have x squared, and just 1x here. So the ones that are common are these in the middle. Now, not necessarily the case in the middle like that, as you saw on the homework last time, but in this situation, they are in the middle. So I'm going to go ahead and bring down the negative 2x cubed because nothing happened to that one. However, negative 4x squared times negative 4x squared is going to get me negative 8x squared. Because negative 4 minus 4 is like if I borrowed $4 from you and I took 4 more, I now owe you $8. In black, I'm bringing down that negative 8x because nothing changed. And this is going to be my final answer. Okay, and it's in standard form because it goes 3, 2, 1 in the powers. Okay, so that's a summary of the multiplying the factors, which I feel like in the whole chapter, that is the hardest part. Now let's go ahead and continue. And you're going to need your graphing calculator for this, so please get that out. And I would make sure to clear out your y equals here. Let me get my computer set up so that you can see both. Okay, it says graph the cubic function x cubed minus x squared minus 12x on your graphing calculator. Use the window negative 10, 10 and negative 50, 50. So before I do anything, I'm actually going to do this window before I do anything. Okay, so I'm going to go ahead and press that window button, which is going to light up in red for you. And if you look here, the x min, this is basically your min, and this is going to be your max. They're already set up for us because that's standard. Our standard window will always be in the tens range, so negative 10, 10. So I'm going to go down, press the down button, till you get to the y min. Now remember, the x scale and the y scale just means how much you're going to go up by, 10s, 20s, that kind of thing. But here it tells me the y min is going to be negative 50. So in my graphing calculator, I will click negative 50, press down. And then my max here, this is my max, is going to be a positive 50. Put that in. Now, when you're going by 50s, you can go up by 1, but that's kind of a lot in my opinion. So maybe I'm going to go up by like 2s, or I'm going to go up by 5s maybe. I'm just going to go up by 5s. Okay. So now I'm going to go ahead and press the y equals so that I can get this function here into the graphing calculator. I'm going to erase all of this just so that we have some room. So go to y equals, and let's type this in. Now, the hardest part, in my opinion, is getting the x cubed in. If you don't remember, make sure you're paying attention. You press that x button. Okay, and maybe I'll show the history here so you can see what I'm pressing. Then you want to press this arrow up button, which is technically called a caret. And then 3. That gets you that x cubed we're looking for. Now, if you notice here, it is flashing right here up there. That means we need to get it back down. It's still in the exponent. So to press the right button. Now from here, I think you guys are pretty good at it. So minus x squared. Okay, minus 12x. Now be careful because remember, you don't want to hit that negative button. We are subtracting here. Now go ahead and press graph. There we go. We see this nice, pretty graph. Now, if you look here on this graphing calculator, hopefully you can see it on yours too, we want to always graph the y-intercepts, and we always want to graph the x-intercepts on our paper. So I'm going to go off over here, and I'm going to go ahead and graph that. So it looks like we have an x-intercept at -1, 2, 3. So I'm going to graph that in, -1, 2, 3. I always like to get all of my graph on paper before I start to answer all these questions. I have another y and x-intercept here where it intersects at that 0, 0. And I have another x-intercept at 1, 2, 3, 4. 1, 2, 3, 4. Okay, so I want to make sure I have all of those ones on there. I have the y-intercepts and the x-intercepts. Okay, now I'm just going to sketch this in. Looks something along the lines of this, and I would accept that. As long as you have your x and your y-intercepts, I'm happy. Now the next part that you have to do when you're graphing your x and when you're graphing these functions is to find your relative max and your relative min. Okay, so when you look at these here, we have this guy in red and we have this guy in green. One of them's a relative max and one of them's a relative min. Think about it for a second and see if you can tell me what it is. Well, in red, we have a relative max. So I'm going to put relative, REL, max point. And then in green, I have a relative min. Now we call it relative max and min because there are points that are going to be higher than our max. If you look, if I draw that in, there are points here that are going to be higher than it. So it's not the absolute max, okay, like our parabolas were in last chapter. But relative maxes and mins mean that we have some kind of max or min point, but it's not the absolute max or min. So we have to find those in red and green. Now remember how to do that. We always have to press second trace and maybe make a note for yourself. When you're trying to find your relative max, you have to press second and then trace. Okay, so second, trace. Okay, we want to calculate the max first. I'm just going to go left to right. So I'm going to press option 4 for max. And remember, you see this left bound on your calculator. I'm going to put my pointer right here. You want to go left of where you think the max is. So in my pointer here, that's where the max is. I'm going to go left of where my pointer was. I'm going to go left, 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 left. Somewhere around there, that's left of where my pointer is. Press the enter button. Now it says right bound. You want to go right of where my pointer is. Right, 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 right. Press enter. That says, do you still want me to guess? Yes, calculator, I do. And the calculator tells me it's about -1.69. So I'm just going to say like -1.7. And then the y value is at 12.59. So I'm just going to say 12.59. 2.6 is my relative max. Now I want you to take a minute and I want you to do the relative min on your own. Again, I would press pause right now. Please don't cheat yourself and actually give it a go and see if you can do the relative min without me, because that's obviously the ultimate goal. Hopefully you press pause, but I'm going to walk you through it even if you didn't press pause. Hopefully you learned something from watching me. Okay, but if you didn't, that's okay. Second, trace. We're going to go to min now, which is option 3. And now here, if I put my pointer here, there's the min. You want to be left of where my pointer is. So I'm going to go all the way close to it. And if you look, my cursor is somewhere left of my pointer. Press enter. Now it says right bound. That means go right of where my pointer is because I'm pointing right at the min. So somewhere on the right, doesn't matter where. Enter. You still want me to guess? I want you to still guess. And it tells you that your relative min is going to be at 2.36. So I'm just going to say 2.4, just round it up. You don't have to round, it's not a big deal. And then it says negative 20.74, so negative 20.7. Okay, so that's my relative min point. Okay, my relative min, I'm going to rewrite that, it looked bad, is going to be at 2.4, comma, negative 20.7. Now I'm done with the calculator. I don't need that anymore. And now let's answer the questions. Now that we have this graph, we're going to answer the question. Hopefully you know the domain and the range of all cubic-like functions. They go forever to the left, forever to the right, forever up, and forever down is all real numbers. And we represent that with negative infinity to positive infinity. And that's for the domain and the range. Your x-intercepts and your zeros are pretty much the same thing, but the x-intercepts represent the numbers in the graph. And then the zeros represent the solutions of the function. So my x-intercepts here in blue are going to be negative 1, 2, 3. So negative 3, 0, 0, 0, and 1, 2, 3, 4, 4, 0. Now again, our zeros represent the same exact thing, but now we're basically just going to take away the zeros. And our zeros are negative 3, comma 0, comma 4. It's just basically those x values of your x-intercepts. Now my y-intercept is going to be the same thing as my x-intercept, and it's okay. So right here, that origin 0, 0 is going to be also a y-intercept. You're only ever going to have one y-intercept. You can never have more than one, and then it wouldn't be a function. Okay, relative max, it's asking you what it is and where it's located. When it asks you where it is, and my relative max was in red, it's always your y value first. So it's 12.6, and then the x value is negative 1.7. That was in red. Now it asks you for the relative min. Now I'm going to try not to write the y equals so that you don't get used to just me always putting the y equals in. The relative min, that means what is the lowest y value on this graph? It's negative 20.7, and it's located at x equals 2.4. Interval of increase and decrease is something that people struggle with all the time. If you like highlighters, get them out. I'm going to do interval of increase first and then interval of decrease. Now, I actually don't do it in order. I kind of just do it piece by piece. So I always start left to right. So when I go all the way to the left, I always start at negative infinity, always. It's always your x value. If you look here, I am increasing of negative 1.7. Okay, so I go from negative infinity to negative 1.7. Where I stopped at negative 1.7 is where I now begin to decrease, because that's what the max and the min do. They change the direction of the function. So I'm going to now start to decrease from negative 1.7, hit at 2.4. Okay, so I have negative 1.7 comma 2.4. It's always those x values. You can see here, that's where it's starting, and that's where it's starting, and that's where it's stopping. Okay, didn't have to draw those in. I was just showing you. Now we're going to go back up, and look, we're going to start to increase, and we always end at positive infinity. Even if the arrow's pointing down, we're going all the way to the right, and the right is the positive infinity. So where I stopped my last one, I'm going to start my new one. So 2.4, and I always end at positive. So if you look here again, where I stop is where I then start. Where I stop is where I then start. It kind of just all flows together. Start to increase, then decrease, then increase. Okay. Now let's start doing some examples with transformations. You guys were doing really well with this yesterday. The first thing I look at is the powers. That means that I have to have to the fifth power, to the third power, to the fourth power in my transformations. It's my parent function. I'm going to write out my original formula for transformations. Remember, the A value tells me if I'm stretching, compressing, or reflecting. Then I have x minus h. The h tells me left or right. And then some number, because we don't know, it's going to be the power of 5, power of 3, power of 5, power of 4. And then plus k, and the k tells me up or down. Okay, so this piece always tells me left or right. This piece always tells me up or down. And then the A value, stretch or compress. Okay, so we are stretching by a factor of 3. That's that A value out in front. The A value out in front. And then it says I'm going to go right 2. That's the H value. So that means I don't even have a K in this formula. And you can use the ones down here as examples to look off of. Okay, that's what it should kind of look like. So I'm going to have g of x, because that's our new function. Okay, that's what we're looking for, is equal to that factor of 3 in the front, and then translate 2 units to the right. 2 units to the right is going to be x minus 2. And then all to the power of 5, because that is the guy right here that we're looking at. And that one's done. I would always go back and check and make sure that that's right. This piece says stretch by 3. This piece says go right 2. You guys are good at looking at it and telling me the transformations, but being able to make the function is the hard part. Okay, it says reflected over the x-axis and translated 3 units up. Okay, so we have this reflection over the x-axis is important, and then we're going to go 3 units up. So I'm going to erase my highlighters up here. And it says reflected over the x-axis. Remember, reflecting over the x-axis is this guy right here by the equal sign. Okay, there's a difference between the x-axis and the y-axis. So I'm going to have g of x is equal to that equal sign, that negative next to the equal. That means reflection over the x. Then translated up 3. That means I don't have an h. I just have this k value. So I have x cubed, because that's the function I'm in. And then I'm going to go up 3. So plus 3. And I'm done. Remember, because up or down is not in parentheses. That's the number on the outside. Okay, the next one. Vertical compression of a factor of 1. Remember, again, that's that A value. Reflected over the x-axis and translated 1 unit to the left. So here we go. I have g of x. If I'm reflecting over the x-axis again, just like we did last time, that negative's by the equal sign. Then I have a stretch by a factor of 1/2 goes in the front. And then left 1 unit, that's the h value. I don't even have a k value here. Okay, so I have x plus 1, because that means left. Now look back and see what power we're in. We are in 5. So I'm going to go ahead and put that degree of 5 there. Again, there's nothing to write here because we're not going up or down anything. Okay, last one. We have a vertical compression of 1/3, and then we are going down 2. and our power is 4. So I have g of x. We're not reflecting, so I'm not going to put that red negative here, but I am compressing by 1/3 like last time. That goes out in front. Now I'm going down 2. That's that k value right here. That means I don't even have an h value. So I'm just going to have x to the power of 4. And then down 2 would be that -2. And I'm done. Okay, now the last part. I think you guys did really, really good with these ones. Determine the transformations and then graph it. So here we go. There's 2 transformations here. I have this 2 and I have this -3. We have to talk about both of them. The 2 means I'm moving left 2, and then that -3 means I'm going down 3. So that is going to be now that starting point when I'm graphing these cubic functions. Left 2, think about that. That means I'm going left 2, which means -2, and then down 3. Now, I always do points that are above and below, so -3, -4, -1, and 0. And we're going to go and get out our graphing calculator and either plug those numbers in or go to y equals, and you're going to go ahead and plug into our graphing calculator. Okay, so you want to go to y equals, clear it out, and I'm just going to type it in. So parentheses x plus 2, parentheses with the arrow button up, 3, go to the right, -3. Now to get your table, you press second, graph, and there's your table. You want to fill in those answers. So I have -3, -4, -4, -11, and then -1, -2, and then 0, 5. So I'm going to go ahead and graph that now. -2, down 1, 2, 3. And then I'm going to have these ones. And then I'm going to have 0 up 5, 1, 2, 3, 4, 5. And then I'm going to have -4, 11, which is somewhere down here. And go ahead and graph that out. Now you can always go ahead and check your graph by just looking at the graph to make sure it kind of looks like what you have. Okay, which ours does. Okay, maybe not as nicely as the graph on the calculator, but remember ours is going up by 50. So this is technically 50 here because we never changed our window. If I press zoom 6, it resets it. And then it looks a little bit better. It looks more like our graph here. Okay, we got one more. Here we go. -1/2. This negative means I am reflecting. So reflect. Now there's a difference between the x and the y. This one is the x. It's right next to the equal sign. So over the x-axis. This would mean reflecting over the y. If I went like this and put it in to parentheses here. Okay, if that was in parentheses right there, that would mean reflect over the y. Now this 1/2 means I'm going to compress by 1/2. Now, I did not move left, I did not move right, I did not move up, I did not move down. So that means that I'm going to be starting at 0, 0. Now let's go to our y equals and find out some other points. So I have negative now, not the minus sign, the negative right here in red. 1 divided by 2. Parentheses x, close it up, little caret symbol or the arrow up, 3, and press second, table. Now we get some points above and below. I have -1.5. I have -2, 4. And I have 1, -0.5. And I have 2, -4. Let's go ahead and graph that. 0, 0, -1.5, 0.5. And then 2, down 1, 2, 3, 4. And then up 1, 2, 3, 4. And then this is our graph. Okay, so hopefully this helped you review every concept that we've learned in Chapter 5 so far. So please go show the sub your notes and get your homework. You should be able to finish before you leave. Some of these questions are very fast. I just took my time when I was explaining today. I hope you have a great weekend, and always remember, be kind and smile.